Okay, Assalamualaikum and a very good morning. Okay, everybody, we continue with last subtopic in functions and graph chapter. So this is subtopic 9.4, exponential and logarithm function. Okay, so first we will look at what is exponential function, the definition. So an exponential function is defined as fx equals to a power of x, where x is a real number and a cannot be 1 and a must be greater than 0. So this is the definition. Okay, so there are a few cases that will apply to this exponential function. The first one is when your a is greater than 1. Okay, so we want to look how is the graph look like. Okay, so when a greater than 1, which is positive, so the first one, when x equals to 0, okay, then your y will be 1. Why is it 1? So if let's say you substitute any value here, let's say I substitute a equals to 2, so I will have fx equals to 2 power of x. So in this case, we substitute x equals to 0. So now your x becomes 0. So it will be 2 power 0. So 2 power 0 will be 1. So that's why you have 1 here. Okay. When x approaching infinity, meaning that your x is getting a big number. Okay. Let's say you substitute x equals to 1, so 2 power 1, it will be 2. So if you substitute x equals to 10, so 2 power 10, what is the value for 2 power 10? You take out the calculator, 2 power 10, you will get 1024. 2 power 100, because in this case x is approaching infinity, meaning to say it is getting to the biggest number. So 2 power 100, you will get 1.27 multiply with 10 power of 30. So it's getting a bigger number, right? So this is increasing to y is approaching infinity. So that's why we have this y approaching infinity. So when x is approaching negative infinity, meaning that is going to negative side. This is going to positive side, kan? Okay, so your y will be approaching 0. Okay, so you can try. Let's say you substitute 2 power negative 1. What you get will be 1 over 2. 2 power negative 10. 2 power negative 10 is 1 over 2 power 10. So 1 over this one, kan? So ini 1 over 2 is 0.5. 1 divided by 1024 will be 0.0000098. Okay, it's approaching 0. Okay, so how your graph will look like? It will be like this. Okay, you will touch at the coordinate of 0 1 here, and then it will pass going here, meaning that the second point is when this is approaching infinity. Okay, your y will be approaching infinity, positive infinity. Number 3, when x is approaching negative infinity, then your y will be approaching 0. Okay, can see from the graph, yeah? Okay, so this is the first case, right? Second one is when fx equals to ax is the same, but then now your a is between 0 and 1. Just now is a greater than 1. In this case, is a is between 0 and 1. So this is the basic property. Same thing, you can substitute any value to check. Okay, so for x, all real number, your fx is always greater than 0. When x equals to 0, then your fx or your y, in this case, equals to 1. When x is approaching infinity, then your fx is approaching 0. When x is approaching negative infinity, your fx will be approaching infinity. Okay, so you can sketch the graph. Okay, how is the graph look like? Okay, it will touch at the coordinate of 0 1. Okay, so this is the graph look like. Okay, okay, so this is the example. So Example 1, there are 7. Another example in the example 1. Okay, A, B, C, D, they are using base A equals to 3. Okay, what change here is the value of your x, the power. Same goes to E, F, G. They're using 2, -2, and 1 over 2. Let's look at the graph. Okay, sketch the graph. Okay, the first one is y equals to 3x. So your A is 3. Okay, 3 is greater than 1. Okay, so in this case we will sketch it like the first case just now. Okay, so when x equals to 0, then your y will be 1. So you will have a coordinate of 0, 1. When x approaching infinity, then your y will be approaching infinity as well. When x approaching negative infinity, then your y will be approaching 0. So your graph will be like this. Okay, same with the first case. Okay, so domain will be negative infinity to infinity. Domain, we will look at the value of x-axis. Range will be at the y-axis. Okay, how about same A equals to 3, but then your power is negative x. Okay, when x equals to 0, then your y will be 1. When x equals approaching infinity, then your y will be approaching 0. When x approaching negative infinity, then your y will be approaching infinity. So how your graph look like? Okay, like this. Because 3 negative x, you can change to the second case just now. So this is 3 negative 1 power x, can? So 3 power negative 1 is actually 1 over 3 power x, x. So in this case, your A is between 0 and 1. This is second case where your x is real number. So it's the same, right? Okay, how about C? C is 3 power x plus 2. Okay, so x plus 2, nampak ya? The power is x plus 2. Okay, when x equals to 0, okay, so when x equals to 0, so it will become 3 power 0 plus 2. So this one will be 3 square, so you will have 9, kan? Okay, so y equals to 9. So your coordinate will be 0, 9. Okay, so when x approaching infinity, then your y will be approaching infinity as well. Okay, when x approaching negative infinity, then your y will be approaching 0. So your graph will be the same like the first case, but then what change is your y-intercept, okay, at y equals to 9, right? Okay, so same thing, domain and range also the same. Okay, how about D? D is 3x minus 2. Okay, when x equals to 0, then your y will be 3 power 0 minus 2, which is 3 negative 2. So you will have 1 over 9. So your coordinate will be at 0, 1 over 9. Okay, then number 2, x approaching infinity, then y will be approaching infinity as well. Because okay, infinity is a very big number, kan, di sini. If we substitute lah, y equals to 3, this one, y equals to 3, a big number minus a small number 2, you will still have a big number, kan? So that's the concept lah, right? Number 3, when x approaching negative infinity, then your y will be approaching 0. So the graph will be the same. What change is only your y-intercept. It will touch at the point of 0, 1 over 9. Okay, same thing. Okay, let's continue. Y equals to 2 power of x plus 1. Okay, this one will be different because plus 1 in this case belongs to the whole 2 power of x. It is different when this is like this, okay, 2x plus 1. Plus 1 belongs to this x, so x plus 1 belongs to 2, but in this case, plus 1 is belongs to 2 power of x. Meaning to say, you substitute the value of x, then you find the value, 2 power of that x value, then you plus with 1. Okay, so when x equals to 0, then your y will be 2. Why is it 2? Because 2 power of 0 plus 1. 2 power of 0 is 1. 1 plus 1 is 2. So you will have a coordinate of 0, 2. Okay. When x approaching infinity, then your y will be approaching infinity. Okay. When x approaching negative infinity, then your y will be approaching 1. Why is it 1? If y equals to, if we have only y equals to 2x only, okay, when x approaching negative infinity, then our y will be approaching 0. So since we have plus 1 ini, meaning that your whole graph will be moving up 1 unit. That is the asymptote. Okay, so alright, you will have that horizontal line at y equals to 1. So your graph will be going up 1 unit and touch at the coordinate of 0, 2. Okay. So fx equals to 2 power of x plus 1. Right. Okay, gy equals to half x minus 1. So this is the second case where your a is between 0 and 1. Okay. The application, the concept will be the same like previous. So 2 negative x minus 1, when x approaching 0, then your y will be approaching 0. When x approaching infinity, then your y will be approaching negative 1 because your graph is going down 1 unit. Kan? When x approaching negative infinity, then your y will be approaching positive infinity. So your graph will be having asymptote at y equals to negative 1, and then your graph will be going down 1 unit. Okay, macam begini ya. Okay, next, y equals to negative 2x. Okay, so from here, you already can imagine what is the graph of this function without that negative sign. So it should be the same with the first case. Okay, like this kan, the graph. But then since all the value of y we multiply with negative, so it will reflect across the x-axis, reflecting about the x-axis. So you will have that negative 1. So that's the graph. Okay, it will reflect about the x-axis because all the positive value we will multiply with negative 1, so everything will be below x-axis. Okay, so this is the graph for y equals to negative 2 power of x. All right. Okay, find the domain and the range of the following function and thus sketch the graph of the following exponent function. Okay, if you really look at here, there is a special case here, e. Okay, what is e in this case? Okay, what is the relationship between what is the value of this e? If you press in your calculator, okay, if you press in your calculator E0, okay, E0, you will have a value of 1. You can check. Okay, so what is the value of E? E is a special base in our real number. This E is equals to 2.71, 2.718, and so on, but we just take 3 decimal places here. E1. Okay, so this is the value for E. Okay, E1. So E1, if you remember just now, our function for the first case fx equals to ax, where a greater than 1, ataupun the second case is fx equals to ax for a between 0 and 1 kan. So since here, okay, here is our a is 2.718, so we will consider the first cases, okay, because a is greater than 1, since we know that e1, okay, e1 is equals to 2.718, which is greater than 1, right? Okay, so we look at this example, fx equals to 1 minus e2x. Okay, e2x, 1 minus e2x, right? So the first one, to avoid confusion, we rearrange the position first. We put negative e2 plus x in front plus 1. Okay, so when x equals to 0, then your y will be equals to 0. Why is it like that? Okay, you can substitute inside here. Y equals to negative e 2 times with 0 is 0 plus 1. Okay, e0 is 1, negative 1 plus 1 is 0, so that's why you have 0. So you will have 0 0 here. Okay, when x approaching infinity, then your y will be approaching negative infinity. When x approaching negative infinity, then your y will be approaching 1. Okay, so that is the asymptote here, plus 1. So there will be a horizontal line at y equals to 1. Okay, so that's the graph. Why is it below here? Because we have negative here, okay? Okay, y equals to 1 minus e2x, right? So that is the domain, that is the range. Okay, let's look at the second example. Okay, so basically for this exponential function, their basic function is y equals to ex sebenarnya, ex. Okay, for x in real number and your e is actually greater than 1, so your basic graph is like the first case. E0 is when you substitute x equals to 0, then you will have 1 here. So this is your graph of y equals to ex. Okay, so in this case, if you have fx equals to ex and then plus with 5, meaning that this whole graph will be moving up 5 units. It will moving up 5 units. So from here, when x equals to 0, then e0 is 1. So 1 plus 5, your y will be 6. Okay, when x approaching infinity, then your y will be approaching infinity as well. Then when x equals to approaching negative infinity, then your y will be approaching 5. Okay, approaching 5 because you have asymptote at y equals to 5. There is a horizontal line there, right? So what happened to your graph? This graph, right? It will be moving up. Okay, they are moving up at, and then it will touch at 6. Okay, 0 6, the coordinate of 0 6, right? Can understand, kan? Okay, so fx equals to negative x plus 5, right? The previous example, y equals to negative e2x plus 1. Okay, so the first one you consider this one, e2x will be, the graph will be like this as well. Okay, all right, and then you will multiply with negative 1, then your graph will be going down ke bawah, it will reflect. Okay, and then this whole dot line will be plus with 1, then your graph will be moving up here. Okay, but then it will not touch this horizontal line because this is your asymptote, kan? So you will have the graph here. Okay, you can refer to the previous example just now. Okay, next example, negative e negative 2x. Okay, when x equals to 0, then your y equals to negative 1. When x approaching infinity, then your y will be approaching 0. Then when x equals approaching negative infinity, then your y will be approaching negative infinity as well. So how is the graph look like? Okay, so why is it like this? Okay, because here kan your power is negative nih, this one. If we first consider fx equals to e negative 2x, your graph is actually here. I okay, excuse my bad lukisan, yeah, sketching of the graph, very bad. Okay, so the red line is for x, e negative 2x, and then since we multiply with negative 1 in front here, then it will reflect. Okay, reflect across this x-axis, then you have this line, the blue line. Okay, all right, that is how we sketch the graph for exponential function. So in exponential function, there is a special base. That special base is e. So the value of e is 2.718, with a condition that if you want to press in your calculator, you must put E1. Because if you clear your history in your calculator, let's say you clear everything, then you put E, okay, then put you just put E, you just put E, so, and then you press equal, okay, then your calculator will be give you 1, because from your history this answer is actually the calculator read as E0, so E0 will give you 1. So that's why I'm saying you to find the value of E, base E, so you must press E and 1, then you will get 2.7118. Okay, how to press E in your calculator? You press shift and press L. You can see up here there is a small icon EX. Okay. Okay, next we look at the logarithm function. What is logarithm function? Okay, it is defined as fx equals to log bx. X is real number and b is greater than 1, right? So there are a few cases as well, like exponential. Fx equals to log bx, and x is real number and b greater than 1. When x equals to 1, then your y will be equals to 0. Okay, when x equals to when x approaching 0, then your y will be approaching negative infinity. Okay, for the first properties, you can try using you can try find why is it y equals to 0. You can try using your calculator. Log b must be greater than 0, because your calculator have only base 10, so you use that log 10 and x equals to 1, then you will have 0. You can press in your calculator log 1 equals to 0. Okay, when x approaching 0, then y approaching negative infinity, then when x approaching positive infinity, then your y will be approaching positive infinity. Okay, how is the graph look like? There will be a coordinate of 1, 0 there. So this is the graph. Okay, you must always remember how is the graph look like. Okay, domain function 0 to infinity, range will be negative infinity to positive infinity. Okay, b is log bx. X is still real number, but then your b is between 0 and 1. Okay, so when x equals to 1, y equals to 0. When x approaching 0, then y approaching positive infinity. When x approaching positive infinity, then your y will be approaching negative infinity. Okay, so how is the graph look like? It will be at the other side, can? It's the same side, but then reverse, right? Okay, so this is the graph. Okay, so example, y equals to ln x. Okay, what is ln x in this case? How we want to find this ln x? What is the definition of this ln x? Okay, ln x, for everyone information, ln is actually coming from log e. Okay, Ln is logarithm function with base e. Since base e is special in our exponential function base e, so log e same value. Log e meaning that log base 2.71 e is written as ln. Okay, log e can be written as ln. Okay, there is a ln button in your calculator. That's the function log e. So ln x is actually log ex. Okay, log e ln is equal, right? Okay, so since e is 2.718, meaning that this solution will be referring to case a just now, when your b is greater than 1. Can log, what is the case of a just now? Log ax, x is real number, b is greater than 1. So the graph will be following the first case. How is the graph look like? Begini kan tadi, y equals to ln x. Okay, so we didn't write as log ex. It is very rarely we write in this form for base e only. Okay, log e you will write as ln. Okay, how about the b? Y equals to ln 2x. Okay, so in this case 2x ni 2x minus 1, because the first one di sini, okay, if we look at here, our domain, our x cannot be, will not touch at this value, this line. Okay, x cannot be 0. If you don't believe, then you try press in your calculator ln 0. You cannot get the answer, right? Ln 0. So meaning that ln 2x minus 1, in order to find the asymptote, you find the value of x first. 2x minus 1 cannot be equals to 0. So x cannot be equals to 1 over 2. So you will have this asymptote at 1 over 2. Okay, so your graph will be passing through this, right? Okay, so what is the value here? What is the value there? Ln 2x minus 1. Ln 2x minus 1 will be the same as the first case. Okay? So this value, the x-axis here will be, how to find the value here, since you know that ln 1 is equals to 0. Ln 1 equals to 0. So this value, we put it equal as 1. Okay, comparing this in order to find what is the x-intercept here. So 2x minus 1 equals to 1. So 2x equals to 1 plus 1 is 2. So x equals to 1. Okay, so x equals to 1. Right, the coordinate here will be 1, 0. Okay. Okay, next is, okay, relationship between an exponential and logarithm function. Okay, ax, fx equals to ax, and fx equals to log bx. Kan? There are two cases. X is always real number, but what change is your b? B greater than 1 or b 0, b1. Same thing with this. B greater than 1, b is between 1, and we have a special case where b is equals to e. And then this one also, b equals to e. There are special cases. There is special cases. Okay, when your base is e. So when your base is e, it is actually belongs to this group. When your base is e, it is actually belongs to this group. The graph will be equal. Okay, what change is just the value of the coordinate. The whole graph will be look the same. Okay. Okay, let's look at this example. Given fx equals to 16x, because we want to find what is the relationship. Okay, please take note. Yeah, what is the relationship? fx equals to 16x, find the inverse of fx. Okay, so we let fx equals to y. Okay, sometimes you can also let fy equals to x because it's coming from let f negative inverse equals to y, then fy equals to x. So this is the same. Let fx equals to y, then you have f negative y equals to x. Okay, sama, boleh. This is can be used either one to find the inverse. Alright, so now you have y equals to 16 power of x. Then we want to find x, kan, because x is our inverse. So how to get this x itself? We put log both sides. Okay, log 10 equals to log 10 16x. So log y equals to that power you can bring in front. So how you get this? Okay, you bring log 16 to the other side, so you have this. Okay, now we can say that x equals to log 16y. Why is it like this? We change the base to 16. Okay, in this case this is log 10, kan? Okay, so x we change to log 16, so we have log 16y over log 1610. Okay, over log 1616 over log 1610. Okay, still remember, kan, how we change the base? Okay, ini we can cancel out. This one is 1, so you left only ini. That's why you end up with this. X equals to log 16y, right? So we can say that this is our inverse lah, okay? Because x is this, kan? X is the inverse. So f negative x is equals to log 16x. So you have the inverse already here. Okay, let's sketch. So this is your exponential function. This is your logarithm function, okay? Exponential function and logarithm function. In general, we define logarithm function with base a to be the inverse of the exponential function with base a. Okay, you can look at here what is their relationship. If you have an exponential function with base 16, then the inverse will be a logarithm with the same base. Okay, this is the relationship. So if you have ax, then the inverse will be log ax. If you have log ax, then the inverse will be a power of x. It's the same. Okay, this is very important. You have to memorize, right? Okay, exponential function y equals to ax are 1 to 1 and their inverses exist as follows. Okay, so this is your graph from the first part tadi, kan, y equals to ax. And this is the graph of the inverse, y equals to log ax. So if we look at here, if you still remember, the relationship is inverse to each other. So how to find the inverse from the previous chapter? You are using calculator. Then you sketch the graph by reflecting it across y equals to x, kan? So in this case, the same. Exponential function and logarithm function, how they are related to each other? They are inverse to each other, right? So kena ingat, kena remember, right? So let's look at the example. Given fx equals to ln x, find the inverse, okay? Determine the domains and range, okay? How to find the domain? If you still remember, what is the relationship between the domain range for function and their inverse? Domain f will be equals to range of the f inverse. Range of f will be domain of the f inverse, okay? Ini also coming from the previous video, right? And then you have to sketch the graph of fx and f negative 1x on the same axis. So how we find the inverse? Okay, let's look how we solve this problem. Knowing that fx is ln x, okay? Ln x, so remember, ln is actually log e, right? Log e. So in this case, our b is greater than 1, okay? So we just change this. Log ex, what is the relationship just now? If ax, then dia punya inverse will be log ax. Log ax. If log ax, the inverse will be ax. So in this case, log ex, dia punya inverse will be e power of y, okay? E power of y, but then later on we change to x, okay? This one. Alright? This is, if we directly use these properties, we directly can get the inverse for this ln, which is ex. Okay, ini ya. Okay, if you find it very hard to memorize, then log ex equals to y, then you just bring this e and you push that y up. So you will have x equals to ey. Kan? So x equals to ey, then finally we will change into x form, in terms of x. So we have this ex. So how we sketch the the domain for the function ln is 0 to positive infinity, then range will be negative infinity and positive infinity, right? So the inverse will be the other way around, right? So how to sketch the graph? Okay, this is the very easiest part. So ln x is like this, where this one will be 1, kan? Dia akan touch at that point 1, 0, and you sketch the line of y equals to x, and then this function will be reflecting across the y equals to x. Then you get this function. Then you label f inverse x equals to ex, alright? So this is the graph of ln x and its inverse. Okay. Okay, how about this one? Given fx equals to ln 3x plus 2. Okay, ln 3x plus 2, find the inverse, same thing, find the domain and sketch the graph. Okay, knowing that ln 3x, y equals to ln 3x, is actually log e3x plus 2. Okay, so 3x plus 2 equals to e power of y, we bring it here. Then we get 3x equals to ey minus 2. Then this is actually x equals to ey minus 2 over 3. So this is our function of the inverse. Alright, so this is our function of inverse. So fx equals to ln 3x. So domain of ln inside here, you have to remember that it is always greater than 0. Okay, so x greater than negative 2, definitely it will not touch at this x equals to negative 2 over 3. So the function is defined for domain negative 2 over 3 to positive infinity, range will be negative infinity to positive infinity. And so from here, this is also range of the f inverse. This is also domain of the f inverse. So it's the same. So how to sketch the graph? So since we know that there will be an asymptote here at x equals to 2 over 3. Negative 2 over 3. So this is the line of negative 2 over 3. So your graph will be like this. Right? Okay. And then that is the line of y equals to x. Alright, so this is the asymptote for your f inverse at y equals to negative 2 over 3. So the blue line is the function of the inverse. Alright, very easy, kan? Okay, I think this is the last example. Fx equals to 2 multiply with 3 power of x minus 1, find the inverse. Same thing, the question is the same, find the inverse, find the domain of both function and sketch the graph. Okay, so this one you will have y equals to 2 power 3x minus 1, then 2 multiply with 2x equals to y plus 1. Okay, this one we bring here. And then we have this 3x equals to y plus 1. Just now we have ax, inverse will be log ax. Okay, log ax. Okay, so log form will be log. So we will have this x equals to log 3y plus 1 over 2. This one should be y, sorry. X equals to log 3 y plus 1 over 2. Then we just change this y to log 3 x plus 2, x plus 1 over 2. Okay, so domain will be negative infinity to positive infinity, which is also the range. Range for function will be domain of the inverse. Okay, so how we sketch the graph? There will be a asymptote at y equals to negative 1. So this is the graph. 2 multiplied with 3 power of x plus 1. Okay, and then that is y equals to x. Then this is the asymptote for the inverse function at x equals to negative 1. Okay, so this is the graph for both sketched on the same axis. Okay, this is the inverse, right? Very easy, kan? Okay, I think this example you can try in first. You try first, then we continue in the class later on. All right, I will explain this example there. All right. So okay, I think that's all. I think that's all for this video. I will continue in the class and we will discuss some more which part you don't understand, and I will add 2 or 3 more examples later on. All right. Thank you very much everyone for your kind attention.